Subject in section 3 is about conjugates, and so we're looking at the conjugate zero theorem, and what that says is with complex numbers or imaginary numbers, a plus bi, a is the real part, b is the imaginary part, the conjugate a minus bi is the conjugate. So if this is a solution, a plus bi, then its conjugate also is a solution, where this part is the same, the real part's the same, and then the imaginary is opposite. And this is also true with irrational numbers. So like 1 plus root 5, then its conjugate will also be a solution, 1 minus root 5. Because when we square root, we have plus or minus, just like the I is square root negative 1, so that means plus or minus. So that's why we have a plus I and a minus I. The opposites are of the imaginary part. So conjugates are also a solution when you're dealing with both complex numbers and imaginary numbers. Or sorry, imaginary numbers and irrational numbers. Okay, so here's an example. If 3 plus 2i is a root, name another root. And remember, just the word root also means 0, also means solution. So here's a solution, 3 plus 2i. What also must be there? Because it's a imaginary number, a complex number, that means its conjugate is also a solution. So 3 minus 2i. So 3 minus 2i is also a solution. Okay, here's a more complicated one using those same conjugate zeros theorem. We want to write a polynomial. Okay, so we want to write a polynomial f of x with the smallest degree possible with these zeros, these coefficients, or these roots given. So here are our zeros, or our roots, or solutions. So since I have an I in there, that means its conjugate is also a solution, so that would be plus I is also a solution. If 2 plus I is a solution, that means its conjugate is a solution, so 2 minus I. Now if those are solutions, what are the factors? X minus 0, x plus I, x minus I, x minus 2 minus I, and then x minus 2 minus I. Notice again, or plus I, sorry. Notice that the first term, right, these are the same on the conjugate, and these are opposite. Okay, so I would recommend multiplying conjugates first. So we multiply this conjugate first, x times x, because conjugates all we have to do is first times first and last times last, because the middle always drops out. So we get x squared minus I squared turns to negative 1, so we get x squared plus 1. On these conjugates, these ones are a little bit more difficult. These two, this would be our first term. This would be our first term, and then the negative I and plus I would be the second term. Okay, so we're going to take first times first. So we got to FOIL that out. So we get x squared minus 4x plus 4. And then we got to multiply last times last, so that's negative I times positive I. That's a negative I squared, which turns to a positive 1. So we get x squared minus 4x plus 4, or sorry, plus 5. Okay, so those multiply. Now x minus 0 is just x. So now we need to multiply all these together. Alright, so I'll just do these two, multiply those two, so 2 by 3. So I should get 6 terms, right? And then I can probably combine most of them, or some of them. X times x squared is an x to the 4th. X squared times negative 4x is a negative 4x cubed. X squared times 5 is a 5x squared. And then 1 times x squared is another x squared. 1 times negative 4 is a negative 4x. And 1 times 5 is 5. Now I can combine like terms here. So all I have to combine is the x squareds. So we get x to the 4th minus 4x cubed plus 6x squared minus 4x and then plus 5. Now we can go ahead and distribute that x and finish this polynomial off. So this polynomial, distribute that, and we get x to the 5th. Let me just put this x out there, distribute it. This becomes x to the 5th, this becomes x to the 4th, x to the 3rd, x to the 2nd, and an x. So there's going to be our function f of x. This is to the 5th, this is to the 4th, this is to the 3rd, this is to the 2nd, and this is to the x. So there is our finished answer right there. Here's another one. You can work on this one if you want to. 2 plus root 3, 2 minus root 3, and 2 plus 3i are roots or zeros. Can you write the polynomial for it? So this one is just 2 minus 3i, right? I got to add that conjugate. These two are already conjugates. Now I can write the terms, or the factors. Okay, so we're multiplying these conjugates, right? All we have to do, well, at least the factors first, sorry. So the factor is x minus 2 minus root 3, and then its conjugate, which would be x minus 2. That part's the same, right? The real part stays the same. And then plus root 3. So I guess you could say like the whole number or the integer stays the same in the irrational root 3, right? Root 3 is irrational. That is the opposite. Okay, and then with complex, x minus 2 minus 3i. First part's the same. X minus 2 plus 3i. Okay, now we can multiply conjugates. This, again, this is our first times first. And then on this one, this is our first. And that's our first. So again, we're going to get x squared minus 4x plus 4. And then last times last, since they're conjugates, negative root 3 times positive root 3 is just a negative 3. And then this one is an x squared plus, or sorry, minus 4x. Minus 4x plus 4, and then the negative 3i times a positive 3i is a negative 9i squared. I squared just changed the sign, so it's plus 10. So we have x squared minus 4x minus 1 times the quantity x squared minus 4x plus 14. Okay, and then we have to FOIL that out. That's a 3 by 3. So we get x to the 4th. X squared times negative 4x is a negative 4x cubed. X times 14, x squared times 14 is a positive 14x squared. Negative 4x times x squared is a negative 4x cubed. Negative 4x times negative 4x is a positive 16x squared. Negative 1 times x squared is a negative x squared. Negative 1 times negative 4x is a positive 4x. And negative 1 times 14 is negative 14. Combine like terms, x to the 4th minus 8x cubed. 30 minus 1 is 29. 29x squared plus 4x minus 14. So there's your function f of x. Okay, so if they actually gave us a point like they did it on the finding the zeros one, where it's like f of 2 equals 30, then I would have an a out front here, and I would plug in, and then I could plug in, actually from the very beginning, I could plug in this x2 and plug in my 30 as my y value and find out what that a is that goes in front. But these ones, they're so complicated to begin with, they don't have you do that. They just give you the zeros, and you got to find the factors and then multiply your factors together to find your polynomial. Okay, so here's your homework problem on page 316, number 65. Here are your zeros, 2 and 3 plus I, and you're supposed to write, find the polynomial. Okay, so you could work through this. I'm going to go ahead and do it now. So I list my factors, x minus 3 minus I. Then I write the conjugate of the complex, x minus 3 plus I. Multiply conjugates first. First times first, and then last times last. So x squared minus 6x plus 9, and then minus I squared, so that's x squared minus 6x plus 9, or plus 10, really, because I squared is -1. -1 times negative is a +1, so it's plus 10. Now I got to distribute the binomial there to a trinomial, so that's going to be 6 terms, because 2 times 3 is 6. And now so we can FOIL that out, so we get x cubed, we get -6x squared, we get positive 10x, then we get -2x squared, we get positive 12x, and we get positive, or -20. -20. So we can combine like terms, get our f of x. F of x equals x cubed minus 8x squared plus 22x minus 20. Okay, so that's it for this subject. We'll move on to the next one.